Drop a modern human into an Ice Age winter without specialized gear, and they are unlikely to survive until sunrise. On the Eurasian steppe, winter temperatures reached -40 degrees. At this threshold, exposed skin begins to die in minutes, and every breath drawn into the lungs causes physical pain. There is a common myth that our ancestors survived these conditions by simply retreating into natural caves to wait out the season. But natural caves are thermodynamically inefficient. Stone is a poor insulator that constantly pulls heat away from the body, and these environments lack the ventilation necessary to manage internal moisture. Survival was not a result of finding a lucky shelter. It was the product of proactive, calculated environmental engineering. This modern Arctic research facility represents our current baseline for survival, relying on electric heat and industrially insulated walls to withstand the sub-zero environment. However, archaeological sites across Ukraine and Russia reveal that 15,000 years ago, humans were building engineered houses like this one, using only bone, hide, and stone tools. Experimental reconstructions show that these bone shelters maintained internal temperatures 40 to 50 degrees warmer than the outside air, matching the thermal performance of modern Arctic facilities. To understand how this was possible, we have to reverse engineer these structures using the same principles of physics that modern architects use today. The existence of these structures proves that Ice Age survival was an active process of applied thermodynamics. The first goal for any builder on the steppe was to reduce the massive thermal delta between the lethal surface air and the interior of the home. Construction began with the excavation of circular pits, often reaching depths of 6 to 8 feet. By digging into the earth, these builders utilized the ground as a thermal resource, shielding the living space from the direct impact of surface wind chill. At this depth, the soil provides a stable ambient temperature that is consistently 20 to 30 degrees warmer than the air above. Clear tool marks found in the soil at these sites confirm these pits were deliberate excavations rather than natural depressions. This is the same physics principle behind modern geothermal heating systems, which use the Earth's thermal mass to regulate indoor temperatures. By going underground, early humans didn't just hide from the cold, they weaponized the Earth's thermal mass to bypass it. Above ground, a single-layer wall, no matter how thick, cannot maintain a stable internal temperature in sub-zero conditions. In extreme cold, the primary threat to a structure isn't actually heat loss, it is the accumulation of internal moisture. Builders had to master psychrometric moisture management, the ability to control water vapor within a thermal envelope. If trapped moisture from breathing or cooking freezes inside the wall, it destroys the insulation and causes structural failure from within. Archaeological evidence shows builders 26,000 years ago solved this using 3 layers. The innermost animal hide trapped warm air against bodies. The middle moss layer wicked moisture away. The outermost woven bark blocked wind while allowing moisture to dissipate into the atmosphere. Modern houses use this exact same logic, combining insulating foam, a vapor barrier, and breathable weatherproofing to keep the interior dry and warm. Your ancestors were resolving the same psychrometric challenges as modern architects, simply substituting synthetic materials with engineered organics. On the treeless steppe, erecting a load-bearing structure without timber required a different approach to material density. They used interlocking mammoth skulls, each weighing over 200 pounds, to form a high-density foundational ring capable of anchoring the house against steppe winds. Curved mammoth tusks were used for the roof, providing the tensile strength necessary for a dome that would shed heavy snow rather than collapse under its weight. The interior was heated by a large central hearth, with smaller secondary hearths placed at the perimeter to create distinct warm zones for various tasks. They even managed their fuel sources, processing mammoth dung and bone specifically for burning to ensure a consistent heat output when wood was scarce. This enclosed combustion created a final challenge, a massive surge of water vapor that had to be cleared to prevent condensation. Builders engineered a passive fluid dynamic ventilation system. Small basal openings near the floor pulled in fresh, cold air from the outside. As this air warmed, thermal buoyancy pushed the moisture-laden air upward and out through larger openings designed at the apex of the dome. By mastering both load-bearing mass and fluid dynamics, these builders created a controlled microclimate that functioned as a reliable thermal barrier against the lethal environment outside. Building a mammoth house took several weeks of intensive labor by a large group of adults. This was a significant logistical investment. It required early humans to operate on seasonal calendars, gathering resources and completing construction months before the winter freeze began. Their food storage was equally engineered. They used the permafrost as a natural freezer, digging chambers into the ice to preserve meat throughout the winter. They also maintained complex, layered clothing that weighed over 15 pounds, requiring constant repair to ensure the seams remained windproof. Inside these warm shelters, humans defaulted to a two-phase sleep pattern, 2 4-hour blocks separated by a brief waking period. During that waking hour, while the steppe outside was frozen solid, something changed in the way humans interacted. Observations of communities living in similar patterns show that this nighttime period is when conversation shifts from practical daytime logistics toward the sharing of stories. It is no coincidence that most carved figurines and cave paintings are found in winter shelter contexts. This safety allowed for the explosion of early human culture. Modern Arctic engineers studying these remains have described being unsettled by the precision of these thermodynamic solutions. Our ancestors didn't simply outlast the cold, they engineered the thermal conditions that allowed human culture to develop even when the environment was at its most hostile.